Sreekumar from the University of Arizona as well, same lab as Joe. And he's a master student at the university, and he's has been working on a new project developing a co-pilot for OML using a Gen AI. So uh, the project is still starting, so this is a work in progress, but he will be giving us a snapshot of the progress so far. Okay, Ajay, the
Hi,
floor is
Margaret.
yours.
Thank you for the introduction. Good morning to everybody. I'll just share my screen. Just to confirm, everybody is able to see my screen, right?
Yes, we can see your screen.
Okay. Okay, thank you so much for listening to my talk. So just like Margaret said, we are trying to develop a co-pilot for ontological modeling language. My name is Ajay Sreekumar. I'm a master's student from the University of Arizona. Just like to introduce my team right now. So I work with Professor Alejandro Salado, with Margaret and Joe from the same lab. We also have a researcher from the University of Manchester, a PhD student from UCLA. So what is the challenge that this team got together to solve? So basically, there is a learning curve with ontological modeling language. So beginner engineers starting at the JPL would need to go through like a set of tutorials to understand the semantics of OML. So what would entail a productivity boost for systems engineers to shorten that learning curve as much as possible? So we are looking at two different aspects as a starter, as a base for our operation. First one is vocabulary modeling. So inherently, vocabulary modeling requires expertise with both conceptual modeling as well as the OML syntax itself. So when we create a set of coherent and loosely coupled modeling patterns, that also requires some level of awareness about what aspects are involved in a vocabulary. And every single time you define a vocabulary, you have to explicitly define what dependencies it has, what vocabularies does it borrow from when you are creating a new one. As it stands, OML does have text editors, but it still lacks assist features which like are available to these languages like Python or JavaScript, where there are a lot of assistant features available. When it comes to description model, we have the exact set of same problems, also with the added issue of a lot of manual tasks which are repetitive and if automated can really decrease the developer time. So the research vision we had was, why not introduce an assistant which does a lot of these tasks in the background and shorten the learning curve, as I said. So what we would be doing is we would be reducing the cognitive burden of this syntax so engineers can just focus on their domain expertise. Also, we would be looking to increase the quality of the OML code that they will be making by suggesting them constructs which are extremely relevant. How can you add things that you may not have thought about, or maybe decrease the kind of workflow that you might need to implement? Also, every single time a Copilot would generate a code, we would be validating those codes in real time through the eBNF syntax we already have established. So what this will entail is accelerating the creation of these comprehensive ontologies. You would not need to think a whole lot about these background processes. And overall, we would democratize this ontological modeling process. So the training would be far lesser in this situation. So just a diagram to illustrate the same. As it stands, all of these workflows are manually done in terms of debugging, in terms of explicit vocabulary dependencies, and the coding process itself. If you're using a Copilot, there will be something that's working hand in hand with you and doing a whole lot of these tasks in the background where you focus on the domain level expertise. So what do we take as inspiration? Is there like something that is working like this? That is GitHub Copilot. For those uninitiated, if you use widely used coding languages like Python or JavaScript, there are millions of repositories available which give enough context for a large language model to understand inherently what structural code is, which is grammatically correct, right? So what it does, it provides contextual understanding of a Python developer's interest through natural language. It basically understands prompts. And it also has a pattern recognition that leverages these existing code repositories and provides real-time assistance. So how does the GitHub Copilot architecture work? And what we're taking as reference for our workflow is it takes two things in context for its work, which is if you consider the private code section and the user section in this diagram, the private code section would have the IDE where the coding process takes place. So what GitHub Copilot takes as its overall context is it takes the IDE where you're currently writing your code as well as those codes which are present in the workspace. It considers that to be an entire project to be taken as context. What it does is it constrains the model to work only within this particular project. And the second part of the workflow is the user prompt, which is quite simply like prompting ChatGPT or any open source large language model and telling it to do an operation where keeping in mind it only works within this particular project workflow, right? The second stage of the operation is it interacts with a large language model which is openly hosted. It can be a Claude Sonnet or a ChatGPT. Basically, OpenAI Codex stands for all of these models which are available via an API interface. Now, once again, I mentioned the wide availability of Python and JavaScript. It's already trained on these languages, so it inherently understands what correct code is. So based off these two concepts, we get suggestions to improve our code, and those may be of wide use cases. So an OML Copilot would be building on this level of architecture using certain specialized skills that we need to put in just so that the LLM gives us only coherent code. So what we'll be trying to do is generate syntactically correct OML code based on these natural language prompts. We'll be validating all of these models which are generated in real time to catch errors before reasoning. We would ensure those explicit vocabulary dependencies are always fulfilled and maintained just so that LLMs have this tendency to absolutely hallucinate whenever they generate anything, be it natural language or code. So we would be managing these dependencies to ensure consistency. And every single time the model gives us an output, we would be iteratively improving the output by making it understand what a correct output is and what is incorrect. And we would be overall integrating it with the existing workflows so that the engineers would only specifically focus on domain level expertise. So this is a mock-up of what the final product would look like. I'll just increase the speed here. So consider this to be the IDE or the OML coding workspace. I'm just going to remove the comment because hashtag is not valid OML syntax. The chatbot would be readily available for you guys to use. And the kind of customizations available would be you could add any documents you would need just so that the LLM can use it for reference, different levels of prompt templates you could provide, the different kinds of tools which are built in, and different MCP servers that you can configure for the prompting process. So in this particular regard, we're using a Claude 3.7 Sonnet, providing a document for its reference, which I'll be explaining in due course. And I define a new concept for thermal control systems. This is just a random prompt that I provided just to see its understanding of what it is. And referring this document, it thinks for 5 seconds and gives me a closed loop of different concepts, which it considers to be relevant to be added to a project, and an explanation as to why those concepts are needed. And it again provides me the functionality to create a new file, copy the code, or integrate it directly with the workflow. Something like this. So once again, this is what we're working towards, where all the code that we create would be coherent, would be grammatically correct, and would be logically sound. So what are these unique challenges? I just showed you a mock-up. What are the challenges that are preventing us from seamlessly creating this? One challenge, as we all know here, is OML is a very specific systems engineering use case coding language. It's not widely available. It's not used in a whole lot of industries. So as a consequence, the training examples that we would have is very limited. While Python has hundreds and hundred thousands of examples from millions of repositories, OML does not have that same situation. Secondly, methodology definition with these formal ontologies and viewpoints would require an awareness of this methodology use when we customize these proposals. And once again, I've mentioned this multiple times, whenever we mention ontology dependencies, they are explicitly managed, and LLMs inherently do not have that understanding for a co-pilot to work with. And the things that you put in the model itself, which are when you create a vocabulary, the subparts that you have, that also requires specialized knowledge. So this is building on the Copilot architecture. We have a lot of the same situations going on here since we are using a Visual Studio Code extension. The one major change would be the large language model we would be hosting would not be connected via API. We would be looking to host a large language model within the local machine. This would completely eliminate any sort of data privacy issues, or also generation timings would be lesser since this would be a smaller model and have a real-time updates being given. One more major change is this locally hosted LLM would have a RAG document always for its reference. Now, this can be multiple RAG documents providing different levels of structural context. I will be explaining what those are in the later slide. And we would be implementing certain key concepts in this workflow, which would be intelligent context retrieval. Now I'll explain what RAG documents are. RAG documents basically provide context structurally from different viewpoints, just so that the LLM can use those things for reference based off of the natural prompt I provided. For example, in the earlier prompt, I asked it to generate a thermal control system for a spacecraft domain. It will look at a list of examples that are provided in a RAG document, and it will look at like something that it considers to be quite relevant to that query. It might look at a structural RAG document to understand, okay, what does a concept look like? What should I look at when I'm creating a concept? And another RAG document might look like in a tutorial in natural language, which is something that the systems engineers themselves go through. So think of it as using all of these databases for your generation process for context retrieval. The second part of it is grammar-aware validation. As I mentioned here, any single time an LLM generates the OML code, we would be checking that against a syntax tree we have created from the eBNF syntax that we have available for us. And iteratively, we would be providing it, maintaining the session, letting it understand, okay, this is the error that you created, this is the specification of the error that's created. And in 2 or 3 cycles, generally, we have gotten an error-free OML code without any manual intervention. So before any of these top 3 steps get implemented, we absolutely ensure that the dependency management is done inherently and completely well by specifying that the LLM cannot use any other vocabulary than the one which are present in the workspace. This dependency like completely ensures that there's no hallucination of any additional vocabularies. Now, the last one is something that is a work in progress with by integrating existing workbenches to provide additional text editors or graphical editors in addition to other custom viewpoints. So I'll take your question later. What Gen AI techniques are we using here? Firstly, due to the limitation in the number of examples that we have here, we would definitely be required to fine-tune a model with this training data set. So once again, this would not eliminate all of the problems we have. This will just ensure that the LLM will have structural context, more structural context on what valid tokens are when it generates OML code. The retrieval augmented generation with examples and methodology will ensure that there are different types of context that the LLM can refer to when it generates the OML code. Prompt engineering enhanced with a system prompt. Effectively, a system prompt is an adaptable prompt that we can provide. Which only takes in one particular natural language prompt and adapts itself based on the scenario of the operation. The initial system prompt is just the initial prompt I provided. However, if it generates a validation error, I would be specifying what error it created and how you should go about correcting it. So that is a background process that I would not need to specify. That would just be a system prompt. And again, validation of these OML proposals against grammar and methodology rules. We have created a large parsed grammar tree, which always ensures that all of the code that gets generated is checked on that basis to provide feedback. So the second stage of our operation is the VS Code integration, where what we look for is a locally hosted LLM, and the VS Code extension needs to support ease of integration with these local models, the kind of RAG document support, code context awareness, where it needs to understand it only can take a certain amount of context based on the project that's open, which again would ensure offline or secure functionality and a high level of customizability. We investigated multiple existing extensions like Continue, Code, GPT, and Tabby, and nailed down on Continue because it allows for high customizability and all of the aforementioned functionalities, as well as chat, autocomplete, and edit operations, which GitHub Copilot also impressively gives us. So the current system workflow is something I would like to demonstrate by the demo I have prepared. Basically, it understands your intent, retrieves the relevant examples, generates this appropriate code, validates it against formal grammar rules, and provides iterative improvements until the code meets all requirements. Just to show you this, I have a demo. So when I initialize the workflow, it initializes an embedding model for the RAG functionality. It loads up a database which has 97 examples for its reference for just this workflow. And now it tells me it successfully loaded these examples and asks me to prompt it. And so I prompt something as simple as generate an OML vocabulary for musical instruments. So what it does an initial vocabulary check where it checks what vocabularies it can extend from and retrieves a set of relevant examples. And it starts the generation process. However, you can see the error comes in that no terminal matches hashtag in the current parser. So it tries to add a comment at the very start. So hashtag is not a relevant commenting syntax in terms of OML. So what I do is, this is a system prompt, it's adaptable. I'm not providing it any more information, ensure that all of that is done, and an example for its retrieval process. Again, it has RAG for its reference, and this is the system prompt that it works on. And you can see here in real time, it has generated and iteratively improved on its generation process. And the last message that you see here says that it has learned that the hash symbol is used correctly for defining a namespace alias, which is this. So basically, this is the workflow that we have worked up until now, but we are looking to iteratively refine this process as well as put it into Visual Studio Code. And yeah, that's been the work done so far. I'll take a question now. Yeah.
Thank you so much, Ajay. We have a question from Nicholas.
Thank you for the interesting presentation. In my experience with the vocabulary development in ontologies, OML and OWL and whatnot, there are effectively some guidelines that are important for defining vocabularies. Like, for example, you don't want to have dangled concepts, or you don't want to have, for example, like issues about synonymity, antonyms that are maybe vague. There's actually a book on BFO. It's I think called Building Ontologies with BFO, that has a number of guidelines that are actually important that I would suggest you look at to include as part of some kind of effectively well-formedness check for defining ontologies, whether it's done by the AI assistant or by the user. The second aspect is, I find it actually very useful to think about ontologies in terms of patterns. So again, what are the kinds of patterns of constructs that we want to be able to express? And in a sense, a sign of poor ontological development practice is the lack of patterns, because then it means that there's not been sufficient thought into, well, what do we want to do with this particular vocabulary? What do we want to say, and how do we check that it's been said somehow properly, or that you can actually say such things? So my suggestion would be to think about adding some kind of a support for specifying patterns or auditing whether vocabulary is able to actually express some kind of a pattern of use or patterns of use.
Yeah. I think in the workflow that we're working with, I think we're firstly ensuring that the code itself is like valid. And then obviously like the second stage would be making it seamless. And then we would be looking at like the code improvement process. But that's like a very good point. Like those things about what you generate, having like synonymity and stuff, that is like extremely good suggestion, because we would be looking to improve the code patterns. That's true.
Thank you, Ajay, and thank you, Nick, for the nice question. Oh, another question.
I'll promise not to take too much time. I resonate with what Nick's saying about patterns. I think patterning and such like that is absolutely important, especially as a practicing systems engineer and understanding what those patterns are. You showed a thermal subsystem demo in your video. First of all, I like the demo example that you gave. That really painted a strong picture to me, who, I'm just a working systems engineer, so a lot of the stuff that's going on here kind of flies over my head sometimes. But one of the things I was going to ask is when you populate that and you've got these large language models, did you say at one point that you needed data in order to train them that was domain specific? Did I hear you correctly in some form of that?
Yeah, yes and no, because again, OML itself is pretty domain specific in that you don't use this as widely as Python is getting used, right? So
Right.
effectively, I would more phrase it like the understanding of the syntax and the structural patterns of OML, like how you describe vocabulary, how you define description. There are obviously RAG documents that you can use as a reference for the generation process. However, the LLM's token generation, which its inherent structural understanding, that would require fine tuning. I don't know if that answers your question.
Yeah, I'm thinking in terms of if you have something you're trying to develop, what looked like you were developing a auto-generated OML specification for a thermal subsystem that has very specific nuances and connections in the sense of what Nick was saying. There are patterns that would be very familiar to your thermal engineers when they make that. In the context of and I assume this is where it is, there is some in the large language model has to know about those concepts and patterns. How much data do you think you would need from a domain expert, say a systems engineer or a team of systems engineers, to provide adequate data so that your model is not going to constantly hallucinate, so that you so get a sense of how much you have to train it on. That's basically my question. Do you have a sense on how much training data you would need for that kind?
So my opinion about that is, again, it's just something that's we're iteratively learning about, is once again, I wouldn't need to fine tune in on the specific spacecraft domain in particular, because again, the fine tuning would be just ensuring validity of the code. In terms of if I provided a RAG or a document that it can look for reference, that is where I feel the domain specific knowledge would come into play. Where it inherently understands, okay, that's a valid OML code. Now it'll look at, okay, if I provide it like a thermal control system prompt in natural language, it can directly refer to that RAG example of like a spacecraft domain, which is a complete vocabulary ontology already created. It can already use that for reference and just say, okay, here's a thermal control system based off of a pattern which I'm already seeing in the RAG document. So to answer your question, I don't think we would need to fine tune it. We would need to provide additional RAG examples. That would be my
I don't know what a RAG is, so I'm gonna have to do homework and go read up on that.
So RAG is basically you write the patterns of thermal in a document.
I see.
And then you provide the document to the LLM. So then when it answers, not only relies on its general knowledge, but it can look into the document for insights.
Okay, cool.
Yeah.
All right, thanks.
Okay, thank you very much, Ajay. And now we have